Bienvenidos, Ushamdid, and welcome to another NetAcad Introduction to Python course supplemental video tutorial. In this video tutorial, we're going to be taking a look at Lab 4.1.3.9, where our focus is going to be on prime numbers and specifically how, given a range of numbers, we can go through and iterate over that range and pick off and identify the prime numbers that are in that range. So let's take a look at the activity. Here it is from the Python Institute. Again, it's going to be 15 to 20 minutes, it says, and level of difficulty medium. And this might be a little challenging, but they do give us some really good hints here. Now, having had to do this in both Java and the C programming language back in the early to mid 90s, this was a nice break and a diversion from all of the calendar work we've been doing up to this point. So definitely had to look up the definition of a prime number, and they provide it to us here as well. So a natural number is prime if it is greater than 1. And so that right there should be the first little check mark that you put next to your requirements. The number will have to be greater than 1 and has no divisors other than 1 and itself. So it says complicated, not at all, gives you some examples, and then here's the task. Now this hint down here is going to be very, very important. And you can see that we have to write a function. They've already provided the outline for the function here, and I've copy and pasted this code into the integrated development learning environment idle in a file. And so we're going to work from there like we always do. Now it needs to take one argument, and here it is right there. And we're going to send that in as a positional parameter. Now we're going to return true if the argument is a prime number and false if otherwise. So it says hint, try to divide the argument by all subsequent values. So subsequent meaning values before this number or in that range, starting from 2. And then it says, and check the remainder. Now, as soon as you see remainder, you should immediately be thinking modulo, right? So if the remainder is 0, meaning it can be evenly divided by some number in that range, then it's not a prime number. Some number in that range other than 2 and itself, right? Or I should say 1 in itself, but we're starting from 2. So if some other number in there can be divided into the number you're working with, other than 1 and itself, meaning that the modulo would give us a 0 remainder, that number cannot be a prime number. And it says, think carefully about when you should stop the process. Now, they provide a little hint here, or I should say a little note, saying if you need to know the square root of any value. Now, the solution that I have and that I came up with does not provide for checking for the square root. And I get the output that we have below. Now, there are some, I don't want to say issues, but there are some anomalies. I don't want to say anomalies is not the right word, or issues, but this I plus 1, right? My problem with this is that if the number we're passing in, right, if we're going to start the range at 1, why are we incrementing right out of the gate to send in the number 2, right? So we're incrementing I by 1. Why would we not just say 2, 20 and not have to increment? At least with my solution, the incrementing of things isn't required, other than the fact that they might be thinking that you're going to check to see if the number is greater than 1, right? So they auto-magically increment that for you. But again, my argument is if that's the reason why or one of the reasons why not just start with 2? And then we don't have to say I plus 1, we can just say I. And then we don't have to print out I plus 1, we could simply print out I. But for whatever reason, they've got it started. The range here is starting at 1. So we already know that the number being passed in, remember, based off this up here, a natural number is prime. It has to be greater than 1. So this has to be why they're incrementing it, or they think you're going to come up with some block of code for the function that would require that. And again, I think it's because they're going to give you the number 2 right out of the gate because it has to be greater than 1. But if that's the case, again, why not just start with 2 and then get rid of the plus 1 on the 2 lines below? So, and that's actually what my solution, and again, I'll pull this plus 1 out and I'll show you that it actually works if we just simply start the range at 2, because this tells me right here that in my function, I don't have to check to see if it's greater than 1 because it's hard-coded here in this range that it is going to be greater than 1. And also, another reason they may be doing this is to make sure that they get the number 20. Because remember, it's left-hand inclusive, but right-hand exclusive. So this range is going to be from 1 to 19. Now, they're going to make it from 2 to 20. And so you can see that is kind of the thinking, at least that's my reading of why they're doing it this way, right? Is to make sure that we get the number 2 because they're incrementing it. When they start from 1, they increment it right away, but then also to make sure that we get 20. But again, my argument there is if they wanted 20, why not just do that? In fact, if you wanted from 2 to 20, why would you not just do that as the range? So again, there's a number of things in play here. There's always more than one way to do it. And we can then have an argument about what would be the best way and what would be more efficient. So let's take a look at the code that I have to resolve this issue. And so let's come over here and you can see I've already cut and pasted things in. We've got the original code is all in here. And then here we are under the function for is prime. Now, 3, 4. So we'll space in 4 there. So now the question is, do you have to check to see if the number is greater than 1? Because again, we can see that it's hard-coded so that it's going to be greater than 1. So could we do if num greater than 1, and then the way I'm going to handle this is with a for loop to iterate over numbers in the range. So you could put that there, but if you kept this code, right, if this is the code we're working with, well, we know that it's going to be greater than 1 immediately because they're incrementing the range of 1 right away to 2. So do I have to check to see if the number is greater than 1? So my answer would be no, because this is the range we're working with. Now, if there was a case where someone could come in here and say, negative 91, then sure, you would do a test to say if you're prompting the user to say, where would you like your range to start? Where would you like your range to end? Then I can see checking if the number is greater than 1. But as it stands right now, there's really no need to check that because it's assumed, it's given that it's going to be greater than 1 based off of the code that we have down here. So I'm going to go right into the for loop. So I'm going to say for I in range. Now, they wanted the range to begin at 2. Where are they at here? Yeah, so try to divide the argument by all subsequent values starting from 2. So the range in my for loop, and again, that's this block of the hint code right here, for me, that's the answer to the entire problem, right? Is reading this block of the hint, because that really tells us what we need to do. So starting from 2, and we're going to check for a remainder. Now, if I were to say 2 comma, the question now becomes, are we doing the number, right, the number by itself, or are we going all the way up to include that number? In other words, if we get passed in the number 2, am I checking to include, 2 divided by 2 or 2 divided by 3 and 4, right? If it was 3, I'd have that. If it was 4, I would have this. Because remember, in the range, the right-hand side number there is not included in the range. So if I say 2 num, so we'll say for I in range 2 comma num, and if, and here's where we get into the other part. So if the number modulo I, equals 0 there. So if the number that we're getting passed in as an argument from right here on that call right there, this call to the isPrime function. And so let's take a step back here and let me pull up the drawing tool and let's take a look at the logic so far. So for I in range 1 comma 20. So the first iteration through I is going to be 1, right? So we make the call to the isPrime function and we're testing. So here's think of that as the test. So if this is true, I'll say T. So if this comes back true, in other words, if we return true for this value in parentheses, here's this positional argument that we are calling the isPrime function with and supplying, that is then going to be a positional parameter, right? If that test returns true, which is that's our job to determine, is it a prime or not? If it's true, then we're going to print it out. And again, the number would be 1. So we're sending in the value of 2. And if 2 is a prime number, we're going to print 2. And again, we're using a keyword argument here with our print function. And remember, the reason for this is we want to keep everything on a single line until, of course, we get to the end of our screen, and then it's going to wrap around, right? So if I didn't have this here, so let's say we didn't have the end, right? We would get the numbers 2, 3, 5. They would come a line by themselves, right? 7 and 11. They would come on a line by themselves. But with the keyword argument of end equal, double quotes, we're going to get 2, 3, 5, 7, 11, I think 13. I don't have these memorized, and probably 17, 19. So that's what we would end up getting. So here's the thing, though, and let's look at this real briefly, and we're going to come to the interactive interpreter to deal with this, because this was my sort of internal struggle with my solution to this. So for I, so let's take a step back. So the number 2 is going to get sent in here, right? It comes in where number is 2. The first iteration through this for loop here, 2 gets passed in. So for I in the range 2, comma 2. Now, we talked about this in the course. What happens there? Does this mean I start with 2 and then end with 2? So if it's including 2 but excluding 2, what is the range, right? And this might be something we don't give much thought to, but if I come up here, and I'll show you why this works, right? So if I say for I in, I left out the in my thing there, for I in range 2 comma 2, and actually let me fix that right out of the gate here, and it's going to throw that off a little bit, but that's okay. So for I in range 2 comma 2, let's go ahead and say print I. Now, what do you think it's going to print? Is it going to print 2, or is it going to print nothing? And the answer is the latter. It prints nothing. Because I'm saying start with 2, but don't include 2. So in other words, it doesn't print anything. And this just happens to be extremely convenient, because if I were to say for I in range 2 comma 1, can I say that, right? And I'll say print I. Or do we get nothing back? Because that isn't a range. We can't start from 2 and then go to 1. Just like, and again, it's excluding this number over here. So I can't go from a higher number to the same number and have it print the range out. And the same would be true if I was to say, again, for a larger number, for I in range 999, comma 999, right? I'm saying start at 999 and stop at 999. And Python is going to say, okay, well, that means that we're not printing anything out, right? So it's not going to print the numbers in the range. So when we start with 2 and 2 comes in here, we start with the range 2 and then the number is 2. And again, it kind of skewed over. So now it'd be 2 comma 2. This for loop right here, that range, we're done. The range is over with at that point, right? But if it did come in here and do this test right here, that's where in the hint on the web page, this is where they basically tell you that if you can take the number, right, in this case 2, and do a modulo on it for whatever the range is, and again, starting at 2, but we've got it so that this is not, there's no range here. So when 2 gets sent in, it doesn't come to the if statement, which if it did, and 2 modulo 2 is 0. But if 2 modulo 2 is 0, or if this equation is equal to 0, that means there's no remainder. That means false. It is not a prime number. Yet 2 is a prime number. And so what's happening here is, and I guess I'll refer to it as sort of dumb luck, that my thinking was this, because when this is 1, or this is 2, or this is equal to or less than that number, right? Which we've been told we need to start at 2. We're never going to get to that if statement right there. It's not going to be doing that test, because if it was 2 modulo 2, it would be 0 and we would return false. But that wouldn't be correct, right? Because 2 is a prime number, but it just so happens that the way the range function works is that when the number is 2 and the second number is 2 and the first number is 2, then there's no range, right? So at that point, I could return true after I do my test, and the true again is going to line up here with the for loop, right? And so let me go ahead and let's fill some of the additional code in. So, and again, I just wanted to cover that because again, that's my thinking. That was my kind of internal struggle, because if the number modulo I, right, which is going to be in this range that we're going to be testing with the modulo stuff, if it equals 0, we know that we're going to return false, right? Because the definition over here is if it's 0, your number cannot be a prime. So I'm going to return false. Well, if that's false, then everything else would be true. And that's where I would back up here and say return true. Okay? So if it comes in and does this test, it's going to return false. And remember, when it returns false, we're basically done with the function at that point. We're done. But if it comes in here and it runs this test, and this test is not true, then it's going to return true. And when I say if this is not true, in other words, if the number is not evenly divisible by whatever the index number is, then we're going to return true and say that there's a remainder there, and it is going to be a prime number. Now, there's my code. If I hit, and again, this is very consolidated code. I don't have a check to see if the number is greater than 1 because, again, the code down here is giving away the fact that it's always going to be greater than 1 because they're saying I plus 1. So let's hit F5 and let's see what happens over here. And you can see 2, 3, 5, 7, 11, 13, 17, 19. Let's take a look at the data, 2, 3, 5, 7, 11, 13, 19, 17. So almost by dumb luck, and I call it dumb luck, but it's really what I should be saying is because of the way the range function works, that it doesn't give us a range when it's 2 as the first number and a equal to or less than number than 2 as the right number. For the number 2, it's going to return that it is a prime number. And think of it like this. The second iteration through, we're going to send in 2 plus 1. So we're going to send in 3. So now we have 2 comma 3. So the range with 2 comma 3 is only the number 2. So the first iteration through, we get that 2 is a prime because the value that got sent in was 2 and the range doesn't recognize 2 comma 2. Now when it sees 2 comma 3, which is really, because the right-hand side here, it's going to be the minus 1 of that, basically, num minus 1 is the actual value, not the index position, but the actual value. So then we get 2 modulo 2, and yeah, that does equal 0, and so it's going to say false. So we can argue that, okay, well, that's not good, but my counter argument is, based on how they've got this hard-coded down here, that this is valid, right? That because again, it's giving us the right output that we would expect. Now, here's what I would say is, well, what if I did this? What if I took away this plus 1? Then what's it going to output? So let's go ahead and see. It's going to output the number 1. Right? So as soon as I pull the plus 1 off, remember, that is inclusive. I'm not checking to see if the number is greater than 1. So if it's not incrementing the first value in the range and the first value in the range is 1, I would want to tuck in 1, 2, 3, 4. And again, you'd have to indent all of this, which I'm not going to do, but you would say if num greater than 1. Right? Because that was kind of the first criteria they gave us. It would be, and actually I'll do that. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, right? So that's what it would look like. So now when I hit F5 again and we run this again, we get 2, 3, 5, 7, 11, 13, 17, 19. So it's a little tricky with the number 1 and the number 2, and even the number 3 if you think about it, because 3 for the num here means we're checking if 2 modulo 2 equals 0, and it does. So I guess you could argue that, hey, that's technically wrong, right? Because 2 modulo 2 is 0, but 2 is a prime number. So maybe you handle that with, something else. But I'm basing my code off of this here. And again, if we were to come in here and say, yeah, I want it to be from, and actually if I was to say 1 to 20, then I could do that, right? If I was to say 1 to 20, then I could do something like that, because that's actually going to check, even though 20, again, is not really a prime number. 19 is the prime. 20 is not the prime. 20 is not prime. 21 is not prime. 22 is not prime. So again, they capped it at 20, meaning 19 is the last number that gets sent in. That's the last number we see as a prime. That's the last check that was done for a prime. So now let's get crazy. Let's see, well, what if I put in here 100? And we'll hit F5 and see what values we get. And so there are all the prime numbers. And again, I just kind of threw this print statement in here at the end. So again, a lot was covered here. And this does handle if the use case, if the number is 1 that gets sent in, and if the number 2 is the number that gets sent in, because there's just simply no range. So it's going to return true. But when 3 gets sent in, right, as the num, then the range is 2 comma 3, and really the value for I is going to be 2. And then 2 modulo 2 is equal to 0, but that returns false. We've already captured for For the num being 2, we've already captured that it is a prime number, as you can see over here. And so then we're good. And then from there on out, we're starting at 2, and we're going all the way up to the number. And the +1 down here that was down here earlier could have been to increment that number so that when it comes in here in this range, that's actually giving us one more than the value. And I think I might have mentioned that at the beginning. So again, I still do kind of have a little internal conflict here as to whether or not, this is the best solution, but it's actually a viable solution that works, even though with the numbers 1, 2, and 3, we may run into some challenges, or I should say some things that we're going to have to simply overlook. So that is going to be my solution for 4139. Again, we could have easily left the +1 in here. Down here we'll say +1. And then the number that's going to get sent in is going to be one more than the actual number, because then that number is going to be one more than the actual number, to make sure that we're testing to make sure that it's divisible. And so let's run through one last time, and there we go. 2, 3, 5, 7, 11, 13, 17, 19, and 23. We ran all the way up to 100. So that is going to be my solution. Again, functional solution. Could have been other checks I may have put in there, but again, I wanted to try to consolidate that code as much as I could, and hopefully what I went over has made sense. So that is going to do it for this supplemental video tutorial on Lab 4.1.3.9, where we are looking to find prime numbers. All right, all the best to you in your studies. Thank you so much for watching, and I hope to see you in the next video.